So this is your Gopal. Welcome to Physics Rank Guru. Today we are going to discuss new chapter, that is gravitation. Class 11, gravitation. Okay, what is gravitation? What is gravitational force? Any two bodies attract each other by virtue of their masses is called what? Gravitational force. Any two bodies attract each other by virtue of their masses is called what? Gravitational force. How they attract? So the force due to interaction between the gravitational fields. Suppose this mass has gravitational field. The force occurs due to interaction of gravitational field of bodies. So any body has a field. So due to the field, the body is attracting. So we can discuss Newton's law of gravitation. Newton's law of gravitation. Newton law of gravitation. Newton law of gravitation. So Newton given a one statement. So after he conducting several experiments, so any I will consider two masses. This is m1 and this is m2. m2. So distance between the two masses is r. So what is the gravitational force? The force of attraction between two bodies is directly proportional to product of their masses. The force of attraction between two bodies is directly proportional to product of their masses and inversely proportional to square of distance between them. Square of distance between them. We can write this one. So F is proportional to m1 m2 by r square. So remove the proportionality, we will get F is equal to capital G m1 m2 by r square. This is gravitational force formula. Gravitational force. So what is the gravitational force formula? F is equal to capital G m1 m2 by r square. What is capital G here? Capital G is a universal gravitational constant. Gravitational constant. Universal gravitational constant. The value of G is 6.67 into 10 to the power of minus 11 Newton meter square kg minus 2. So this is value of G. So here you can write G in terms of G formula. G is equal to Fr square. Fr square by m1 m2. So what is the SI unit of capital G? SI unit is what? So here Newton meter square, mass into mass, kg minus 2. This is the SI unit of gravitational force. So what is the dimensional formula? Dimensional formula, we can convert this, you can get m to the power of minus 1, L to the power of 3, T to the power of minus 2. This is the dimensional formula of gravitational. This is the dimensional formula of universal gravitational constant. It is a scalar quantity. It is a scalar physical quantity. So it has only number, no? So it is a scalar physical quantity. So what is the gravitational? You can see the characteristics now one by one of a gravitational force. So gravitational force F is equal to G m1 m2 by r square. G m1 m2 by r square. Suppose we can consider the earth and any body. Suppose I will consider earth and object. The earth mass is capital M and this mass is small m and this radius is what? R. So we can write same gravitational force formula, capital G capital M small m by r square. So what is the vector form of gravitational force? F is equal to capital G m1 m2 by r cube into r bar. This is a vector form of gravitational force. Vector form of gravitational force. We can discuss now characteristics. So here F is equal to G m1 m2 by r square. G m1 m2 by r square. First characteristics is it is a central force. It is a central force. It is a central force. So why? Because you can consider the distance between two masses from this mass center to this mass center. So that's why it is a central force. From this mass to this mass, that's why it is a central force. So it is a central force. Second one, so it is attractive force. It is always attractive. Gravitational force is always attractive force. It is always attractive force. Attractive. It is always attractive. So third one. So gravitational force is independent of medium between the two bodies. Gravitational force is, so it is independent of medium between the bodies. Independent of medium. It is independent of medium between the two bodies. So next one, it is a action-reaction force. It is a action-reaction force. It is action, reaction. It is a action-reaction force. So what is, suppose this is the body 1, this is the body 2. So what is the gravitation force due to first body of a second body? So this is, you can write gravitation force first body due to second one is F12, F1 bar. Gravitation force second body due to first body is F21 bar. So this is action-reaction pair. So here you can write F12 bar is equal to, these both are equal magnitude but opposite direction. So minus of F21 bar. So this is a always action-reaction force. Single force can never exist. Force always exists in pair. Force always exists in pair. So gravitation force is a action-reaction pair. Action-reaction pair. So next one, next characteristic. So this force is valid for point masses. This force is valid for, so it is valid for point masses. It is valid for point masses. So gravitation force is valid for point masses. And next one. So gravitation force is considerable. Gravitational force is considerable when one of the mass is huge. So due to small value of capital G, due to small value of value of mass is small, due to value of G is small. So gravitation force is considerable when one of the mass is huge. Why? Because small value of G. So I will make you feel, so one by one. We can discuss some problems. Question number one. So here two bodies are there. So one is mass M and another is mass capital M. Separated by a distance is R. So here I am asking is, first question is, this is MCQ question. MCQ. First one, F1 2 bar is equal to minus of F2 1 bar. Second one, F net is equal to 0. Third one, acceleration of A12 is equal to acceleration of A21. Fourth one, A net is equal to 0. Fifth one, V1 bar is equal to V2 bar is equal to 0. Sixth one, VCM is equal to 0. Seventh one, VCM is equal to 0. Here VCM is equal to constant. VCM is equal to constant. Eighth one, V1, V2 is equal to constant. So we can discuss one by one now. So here gravitation force of first body due to second body is F12 bar. Second body due to first body is so F21 bar. So first one is valid. So first one is right. So what about second one? So F net is equal to 0. What is F net? F net force is equal to F12 bar plus F21 bar. So these forces are equal magnitude but opposite direction. So we can write here this F21 is minus F21. Both are magnitude of forces are same only. So this F net is equal to 0. So second one also right only. Third one, what is the acceleration of 1 2 and acceleration of 2 1? So you can see. So acceleration. So A12, what is the acceleration here? A12 bar is equal to F12 bar by, so this mass, F12 bar by this mass. What is F12 bar? You can write capital G, this mass, M, capital M by, so due to this small m. So capital M, G, M, capital M by R square into mass. So this M cancel, you will get, so capital G, capital M by R square. So this is A12. You can find out similarly A21. A21 is equal to F21 bar by capital M. F21 bar by capital M. So we can write capital G, capital M, small m by R square into capital M. This capital M is cancelled. So capital G, small m by R square. So here capital G, capital M by R square, capital G, small m by R square. So here A12 is equal to A21. A12 is not equal to A21. So this is wrong. This one is wrong. What about net acceleration? Net acceleration you can find out. Acceleration of center of mass. You can find out acceleration of center of mass. We know what is the acceleration of center of mass. So A is equal to ACM is equal to So we know ACM is equal to M1 A1 plus M2 A2 by M1 plus M2. What is M1 here? So here M1 is small m. What is A1? A1 is equal to, we'll get capital G, capital M by R square. So here M2 is capital M. And what is here? A2? A2 is equal to capital G, small m by R square by M plus capital M. So here minus of M plus capital M. Why? Because this acceleration is coming this one, this is acceleration is going this direction. So minus of this one. But here ACM is not. So see here capital G, capital M by small m, capital G, capital M, small m by R square capital M. So here capital G, capital M, small m by r square by small m plus capital M. So these both are equal. So acceleration of center of mass is 0. ACM is equal to 0. So here ACM is equal to 0. Next you can see velocities are 0. So here velocity not equal to 0. So V1 is equal to V2 is equal to 0. So this is a wrong. So next what, VCM is equal to 0. You can check VCM. We know F net is equal to 0. F net is equal to 0 means. So in case F net is equal to 0, so ACM is equal to 0. VCM is equal to 0. Next VCM is equal to constant. VCM is equal to constant. When VCM is equal to maybe 0, maybe 0. So VCM is equal to constant, must be constant, must be constant. So this is maybe, this is must be constant. VCM is equal to constant. When VCM is equal to constant means ACM is equal to 0. ACM is equal to 0. Here ACM is equal to 0. So VCM is equal to must be constant. When must be constant, ACM is equal to 0. So what about VCM? VCM may be 0. May or may not be 0. So next V1 is equal to V2 is equal to constant. This is also wrong. So here VCM is equal to maybe 0. This is maybe 0. So this one is VCM is equal to constant. VCM is equal to constant. So here V1, V2 is not both velocities are not. This body is move fast. This body is move fast towards this capital M, and capital M is move slowly. So these two velocities is not constant. Okay, na? These velocities are different. Due to the small mass, this is move fastly. This is the capital M. So that is move slowly. This is move slowly towards this mass. Okay. So this is first problem. Second one. So here two masses are there. So first mass is 10 kg is at rest, and second body is 2 kg at infinity distance. So this also rest only. So due to gravitational force, these two bodies are attracting. So when attracting, this first body is moving, this 10 kg body is moving with a speed 2 meter per second. 2 meter per second. So what is the velocity of 2 kg block towards the 10 kg block? What is the velocity of 2 kg block towards 10 kg? You can find out this one. So I will give you option. A is equal to 10 meter per second. B is equal to 2 meter per second. C is equal to minus 10 meter per second. D is equal to minus 2 meter per second. We can discuss now. So when 10 kg block is at rest and 2 kg block is at rest, you can find out first VCM of a first initial VCM you can find out. VCM is equal to formula what? M1 V1 plus M2 V2 by M1 plus M2. So here VCM is equal to 0 due to the two bodies are initially at rest. So VCM won't change. So VCM is equal to 0. So what is M1? 10. What is V1? 2 plus M2 is 2. You can find out V by 10 plus 2. So you will get this one. You will get, so 2V is equal to minus 20. 2 ones, 2 tens. V is equal to, you will get minus 10 meter per second. So why? Because initially VCM is equal to 0. So after that moving, so M1, what is VCM? M1 V1 plus M2 V2 is equal to M1 plus by M1 plus M2. VCM is equal to M1 V1 plus M2 V2 by M1 plus M2. So here VCM is equal to 0. Substitute the values. So this body, second body moves with a velocity minus 10 meter per second. Minus 10 meter per second. We have to consider number of masses. Suppose I will consider this mass is M1 and this mass is M2 and this mass is M3 and this mass is M4. Due to M1, what is the gravitational force? So we have to collect a collection of masses. The force due to any one of the body due to other. So here I will consider the force due to M1. What about M2, M3 and M4? So due to M1, this force is acting this direction. That is I will consider F12. Due to this mass M1, so what about M3 and M1? So this force is M13. Due to M1, this force is F14. So what is the force? What is the net force means here? The vector sum of all the forces. So F is equal to F1 2 bar plus F21 bar F13 bar plus F14 bar. So like that you can add the vector sum of all the forces due to M1. Due to M1 force is the vector sum of all the forces. So this is what principle of superposition. So I will make you feel given one problem. So here three masses are there. This is M and these three are placed in equatorial triangle. This is 2M and this is M. So I am asking is the force due to M1 and 2M. So the force, find force on M and 2M. Find the force on M and 2M is, so Fm is equal to X capital G. Fm is equal to X capital G M square by, so distance between two masses I will consider is A. So A square. And F2m is equal to Y capital G M square by A square. So here find X and Y. X comma Y. The force on M and M2 is, so here force on M and 2M is Fm is equal to X G M square by A square and F2M is equal to Y Gm square by A square. Here find X and Y. So I will consider a small m. Due to this small m, so one force is acting like that and one force is acting like that. So this force I will consider. So I will consider 2m mass. First 2m mass. What are the force acting? The force due to this 2m is, so along this block is F1 and along this one is F2. So here F1 is equal to F2. Why? Because this 2m and m, this is 2m and m. So these two forces are equal. So this is angle between this equatorial triangle is all are 60 only. So F1 is equal to F2. So is equal to F is equal to, formula is what? Capital G 2m into m by A square. So we can write 2 is 2 capital G m square by A square. So this is F. F1 and F2. So in case forces are equal, we know one formula. So what is the net force on 2m is equal to 2f cos theta by 2. 2f cos theta by 2. So why? Because this is a uh, vector form. We know resultant force formula is equal to resultant force F net is equal to F1 square plus F2 square plus 2 F1 F2 cos theta. By using this, you will get this one. F2m is equal to 2F cos theta by 2. In case your two forces are equal, then you will get formula 2F cos theta by 2. So here 2F cos, there 60 by 2 means cos 30. So we can write here 2F cos 30 value root 3 by 2. So these two cancel. So we can write this one F2m is equal to so substitute the F value. So here in F value 2 is there, 2 root 3 capital G m square by a square. So what is the x value here? X is equal to 2 F2m is equal to, here y you will get, y is equal to 2 root 3. Y is equal to 2 root 3. Similarly, you can find out Fm. So Fm you can find out for a small mass. So here one force is acting this direction. So that is, you can consider F2, and this force is acting this direction, thus I consider F1. So here you can write F1 is equal to G m square by capital G m square by a square. What about F2? F2 is equal to, here F2 is equal to 2 capital G m square by a square. So here F2 is equal to 2 times of F1. F2 is equal to 2 times of F1. You can find out the net force. F net is equal to F1 square plus F2 square plus 2 F1 F2 cos 60. 2 F1 F2 cos 60. So here F1 square, this one is what? 2 F1 square. 2 we can write that 4 F1 square plus, so here 2 F1 means can write 4 F1 F2 into cos 60 value 1 by 2. So this one 1 jar 2 jar cancel. So here 5, this is F1. 5 F1 square plus 2 F1 square. So this is 7 F1 square under root. So this is 7 root 7 F1. Root 7 F1, here F1 value is root 7. F is G m square by a square. This is Fm. This is Fm. This is Fm. So here I will get Fm is equal to, given here, x gm square by a square. So here we will get x value is root 7. Root 7. The principle of superposition. So I will make you feel. So consider a rod of, so one rod is placed like that. The rod of mass is capital M and length of the rod is L. So from this rod to a d distance, one mass is placed. That mass is small m. What is the gravitation force between these two rod and mass. You can find out. So this is a uniform rod. So here mass is distributed like that. So it is not possible to find that this is m g capital M small m by r square. So it is not possible. So from this mass to from x distance, I will consider a small element, that is dm, and this thickness is dx. The thickness is dx. So from this mass to, so number of elements are there. So this is the center of this rod. So like that number of elements are there. Infinite number of elements are there. So I will consider one element of a mass is dm and x thickness is dx. And how much distance is there from this x distance? X distance. So we can write this. First we can find out dm. So what is the gravitational force here? df is equal to capital G dm into m. dm into m by, what is the distance between these two? X square. Distance between these two is x square. So you can find out that here dm by dx is equal to this capital M by L. Capital M by L. So from this you can find out dm. dm is equal to capital M by L into dx. So substitute in place of dm. So df is equal to capital G m by L dx into m by x square. So you can integrate this one, you will get a total force, total gravitational force. So F is equal to integration G capital M by L dx into m by x square. So what are the common terms constant terms you can common? So here G is constant, so common. From where to where you can do this integration? From D to D plus L. From D to D plus L. So this is D to D plus L. And find out from D to D plus L. D to D plus L. So G is common, capital M is common and L is also constant. Capital M is constant, L also constant. This M also constant. M also constant. So integration D to D plus L. So here x 1 by x square dx. 1 by x square dx. You can find out this. F is equal to capital G capital M by L into m. You can integrate this one. 1 by x square, you will get minus 1 by x. Minus 1 by x d to d plus n. Now substitute the limits. So f is equal to capital G capital M small m by L. So first minus 1 by d plus L, minus of minus plus 1 by d. So LCM do. So capital G capital M small m by L is equal to, so you can write d minus d plus L by d of d plus L. D of d plus L. So here minus d plus d is cancelled. So remaining term here L is cancelled. Here L is cancelled. So capital G capital M small m by d of d plus L. D of d plus L. This is what gravitational force. Gravitational force. So you can see one more example. So two metal spheres of a same material and each of radius is r are in contact with each other. The gravitation force of attraction between two spheres is proportional to. Suppose, so this is one of the metal sphere and this is another metal sphere. This both are contact each other. These both are contact each other, and each one radius is r. So this radius is r, and this one radius also r only. So here, what is the total distance is 2r. So here total distance is 2r. Total distance is 2r. So what is the gravitational force? Both of a mass, same metal, this mass is m, this mass is also m only. So what is the gravitational force? F is equal to g m into m square by 2r whole square. 2r whole square. So here asking is what? The gravitational force of attraction between the two spheres is proportional to. Suppose I will consider this mass is equal to, in terms of mass we will consider volume, two metal spheres in terms of density given. So this formula you can convert in terms of density. So G, what is the mass? Mass is equal to volume into density. Volume into density. What is the volume formula? 4 by 3 pi r cube into density whole square by 4r square. So we can write this one. F is equal to capital G 4 by 3 pi r cube. Suppose you can constant cancel first. Here proportional asking. Here G is constant, 4 by 3 is constant, pi is constant, and rho is constant. This 4 also constant. So remaining 2 3 is 6, r to the power of 6 by r to the power of 2. So this is proportional to. So 2 1 here force cancel. So F is proportional to r to the power of 4. F is proportional to r to the power of 4. Next one more problem we can discuss. The three uniform spheres each having mass m is radius mass m and radius is r are kept in such a way that each touches to one another. The magnitude of gravitational force of any sphere due to the other two is. So here you can consider the three spheres of a mass is m. These three are touches each other like that. So each of radius is r, means this is mass of this body, this is the mass center to center. So these three are equilateral triangle. So each one angle is 60. So due to this sphere, what about other two forces you can find out? So due to this sphere, this is, I will consider F1 force. Due to this sphere, I will consider this is F2. So these are equilateral triangle. These three forms equilateral triangle. That's why I will consider. So F1 is equal to F2 is equal to F I will consider. So what is the gravitational force? This is mass m, this is mass m. Okay na? So G m square by distance is what? So this is r, this is also r, distance is 2r whole square. So from this you can write G m square by 4r square. So you can find out resultant force Fr. Fr is equal to, we will write F1 bar plus F2 bar. You can find out the magnitude of Fr. You can write F1 square plus F2 square plus 2F1 F2 cos theta. So this is the resultant force. So F1 means F. You can write F square plus 2F square cos theta under root. So 2F square plus 2F square cos theta. So here 2F square is common. 2F square common. 2F square 1 plus cos theta under root. So you can write 1 plus cos theta 2F square 2 cos theta by 2 can write. Cos square theta by 2 under root. So this is resultant force. So Fr is equal to, so here 2 2 is 4, 4 coming outside means 2, F square coming outside means F, cos square theta by 2 coming outside means cos theta by 2. So theta is equal to 60 here. So Fr is equal to 2F cos 30. Cos 30 value Fr is equal to 2F cos 30 root 3 by 2. This 2 cancel. So Fr is equal to root 3F. So you can write resultant force Fr is equal to root 3. What about F here? Gm square by 4r square. Gm square by 4r square. So this is the resultant force. So here uniform sphere of each having a mass m and radius is r are kept in such a way that all are touches each other. The magnitude of gravitational force on any sphere due to the other two is, formula is what? Fr is equal to root 3 gm square by 4r square. A rod of length is L. Rod of length is L. Another rod of this length is what, sir? L. And another rod of length is 2L. Another rod of length is 2L. These two are placed at a distance of L by 2 distance. L by 2 distance. This rod length is 2L. You can find out what is the gravitational force. What is the gravitational force? So this center here. So you can, this 2L center exactly L, from L distance. You can find out gravitational force between the two. GF you can find out. GF. I will give you options. Option A, 2gm. This mass is m and this mass is 2m. This mass is m and this mass is 2m. This rod length is L, this rod length is 2L, and this is placed, separation is 2L by 2. Separation is L by 2. So first option is 2gm square by L square. Second one, 4gm square by L square. C, 8gm square by L square. D, 16gm square by L square. So you know the answer. So write in comment section. So all of you, bye, take care, have a nice day. Today's session is complete. You can meet the next session. Okay. So all of you, please watch my videos and please share, subscribe and like my videos. So all of you, bye, take care, have a nice day.